All right, ladies and gentlemen, good day. Let us begin the study guide review for the Unit 5 test, Part 2. That would be sections 5.6 through 5.10. All right, so the first part is graphing an absolute value equation. So the first thing we're going to do is fill in the table and then go ahead and plot the dots. So we've got this equation right here, y equals the absolute value of x plus 3 minus 4. So we can go ahead and use our calculator. Now again, some of you are going to have a newer calculator, some of you are going to have an older calculator. So I will describe the older calculator as we go, because what you will see on the screen is the newer calculator. So the first thing we want to do is go to our y equals. The absolute value button on the new and old calculators is in the same spot. It's going to be math. And then you're going to right arrow to number. And number 1 stands for ABS. Okay, I'm going to pick number 1. Now, if you've got an older calculator, it's just going to say ABS with a parenthesis. Okay, so you're going to type the same thing. The only thing you need to remember to do is close the parenthesis. So, going back to our problem, we see that inside the parenthesis is x plus 3. So, we're going to type x plus 3. Now, again, if you've got an older calculator, you want to now close it with the right parenthesis. The new calculator, we're going to hit our right arrow key to get outside of the absolute value. And then the last part of that problem, it says minus 4. So we're going to go ahead and put minus 4. All right, now we're going to go to the table, second graph. We're going to, my calculator right now is set up in scientific notation, so let me just quickly fix that. Okay, so I'm going to go back to my table, second table. Okay, so hopefully this is what it looks like. We need to get our table so the -6 is on top, so it matches the table on our paper. Okay, now we can fill in the second column. We can fill in the y values. All right, here we go. So we've got -1, -2, -3, -4, -3, -2, -1. Now, when you're taking the test, you must plot the dots accurately, otherwise you are not going to get full credit. All right, so here we go. So left 6 down 1. Left 5 down 2. Left 4 down 3. Left 3 down 4. Now it's left 2 down 3. Left 1 down 2. Okay, remember it forms a V. Draw your line through the dots. Voila. There's the graph for the absolute value of x plus 3 minus 4. Okay, same thing with the next one. Let's go to our y equals and then fill in the table. So in this one it says x minus 2 inside the absolute value. And on the outside it says plus 5. All right, go to the table. Line up your table with the table on your paper. -1 would be at the top. There we go. All right, let's fill it in. So 8, 7, 6, 5, 6, 7, 8. Plot your dots. Left 1 up 8. Over 0 up 7. 1, 6. 2, 5. 3, 6. 4, 7. 5, 8. Now remember, you should always be getting a V when you're doing absolute values. All right, simple enough. calculator does all the work for us. We just have to remember how to plot the dots. Number 3 and 4, we are solving absolute value equations. Now, remember, you could have two answers, or there's no solution. Okay, well, let's take a look. So, number 3, okay, it equals a positive. That tells us there are going to be two answers. So we're good. So we're going to rewrite the problem with two equations. First equation is x plus 2 equals 8. The other equation is x plus 2 equals negative 8. Okay, do not forget there are two equations. If it equals a positive, we have to get two answers. All right, solve both of them. Take away 2. So the first answer is 6. Take away 2. The second answer is negative 10. That one's done. Now the next one, we first have to get the absolute value by itself. We have to get it alone. Right now it has a plus 2 attached to the back of it. We have to get rid of it. So first we're going to take away 2. So we still have the absolute value of 2x minus 1 equals 5. Now 5 is positive, so that tells me there are going to be two answers. If it equaled a negative, that's where we would have a no solution. Okay? So we're good though. It's a positive, so there are two answers. So again, we're going to make two equations. 2x minus 1 equals 5. 2x minus 1 equals negative 5. Okay, solve both of them. Add 1. Divide by 2. So the first answer is 3. Same thing with the other one. Add 1. Divide by 2. So x equals negative 2. There are the two answers. Okay, page 1 is done. Moving on to the next part. We learned how to graph circles. So first thing we're going to do is identify the radius of the circle and then graph the equation. Okay, now remember, x squared plus y squared equals r squared. Now again, we're not going into a lot of detail. We only skimmed the surface of graphing circles, and we're always going to be, the center of our circle is always going to be at the origin at 0, 0. All right, so this one is set up. We notice that the 16 is our r squared. Okay, so to find out what r is, we need to take the square root, which is 4. So the radius is 4. So we're going to go right 4, put a dot, up 4, put a dot, left 4, put a dot, down 4, put a dot. And as best you can, don't make a diamond out of it. Okay, I will take points off. You need to try the best that you can to make it look like a circle. Okay, number 6. Same thing, we see that the r squared is 64. Take the square root, so r is 8. Center is at 0, 0, so right 8, up 8, left 8, down 8. Draw your circle. Okay, the next part, we're going to go in the other direction. We're going to write the standard form. x squared plus y squared equals r squared. That's the standard form of the equation of the circle with the given radius and whose center is the origin. All right, so if r is 9, r squared would be 9 squared, which is 81. So x squared plus y squared equals 81. That's my answer. Next one, same thing. If r is 12, that means r squared equals 12 squared, and 12 squared is 144. So our x squared plus y squared equals 144. Okay, this next one. This time we are given an ordered pair. So 3 represents x, 4 represents y. So in this case, we're going to replace the x with 3. So 3 squared plus, and please use parentheses, 4 replaces the y, so plus 4 squared, and that's going to be the r squared. Well, 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25, so I find out that my r squared is 25. So my equation is x squared plus y squared equals 25. All right, page 2 is done. Okay, let's go to page 3. Let's do one more with the circles. So again, we have x squared plus y squared equals r squared. So that would be negative 2 squared plus 6 squared equals r squared. Well, negative 2 squared is 4. 6 squared is 36. 4 plus 36 is 40. So my equation is x squared plus y squared equals 40. All right, the next part, okay, now this section number is wrong. I believe that is section 5.7, not 12.1, so section 5.7, dealing with, okay, the rational functions. This is where we have the horizontal and vertical asymptotes, and if you remember, the graph is called a hyperbola. All right, so first fill in the table and graph the rational function, then answer the question. All right, so we want to rely on our calculator a bit here. So let's clear out our y equals. Now when we type this in, we're going to go 1 divided by, and please remember you have to put the denominator in parentheses. So we have x plus 2, close it. And then behind that, you're going to put minus 3. Now we're going to go to the table, and we're going to line up the table with what's on our paper. So that means we need to have the negative 5 at the top of the screen. Okay, let's fill in the table, and then we'll discuss the vertical and horizontal asymptotes. So negative 5 matches up with negative 3.3 repeating. Negative 4 matches up with negative 3.5. The negative 3 matches with negative 4. There's an error message at negative 2. Negative 1 goes with negative 2. 0 matches with negative 2.5. And 1 matches with negative 2.6 repeating. Now, just taking a quick peek at this on the calculator. So that's what it looks like on the calculator. Now remember, there are some boundary lines, again the vertical and horizontal asymptote, okay, where the lines cannot cross. If we look at the vertical asymptote, we see the vertical, if you're looking at the screen, you can see where the arrow's moving up and down. The vertical asymptote is right here. The horizontal asymptote is like right here. Okay, well, the equation helps us determine the vertical and horizontal asymptote. Okay, the horizontal asymptote goes with what's in the back, the -3. The horizontal asymptote is at -3. So that imaginary boundary line is right here at -3. The vertical asymptote goes with what's underneath. Now, you will notice, ladies and gentlemen, and it's really important to look, there's an error message at -2. So the vertical asymptote is at x is -2. Again, there's our boundary lines, our vertical and horizontal asymptote. Again, if you look at your calculator at the screen, you can see that. So, what is the horizontal asymptote? Okay, it's -3, and the vertical asymptote is -2. All right, now I'm going to go ahead and graph this. Okay, so I'm going to go left 5 and down just a little bit more than 3. Left 4, down 3.5. Down 3, or left 3, down 4. Okay, let me switch colors so we can see that a little bit better. So my line is going to go like this. And again, try to draw it as accurate as possible. I will take points off if it's really sloppy. Okay, then I'm going to graph the other ones. So this is left 1, down 2. Over 0, down 2.5. Over 1, down a little bit more than 2.5. So again, it looks like this. And again, you should have arrows on it. So that's what the graph looks like. And again, if you take a peek at the calculator, yep, looks pretty good. All right, so what is the domain? So the asymptotes play a role in our domain and range. Now remember, domain is your x value. So again, my x value, this is my x value right here. Okay, I'm sorry, not my x value, but my vertical asymptote is at x is -2. So my domain is all numbers except -2. Because the lines cannot cross that. My range, which is my y values, and the horizontal asymptote represents what y value cannot be used. So again, it's all numbers except -3. All right, moving on. Okay, the next one, again, I'm going to go to my calculator. I'm going to go to my y equals, and I'm going to type that in. I'm just going to change my bottom to say -3. And behind it, +4. Okay, so this is what the graph's going to look like. All right, again, those numbers are playing a role in the vertical and horizontal asymptote. Let me go to the table, line my table up. Okay, fill in the table. So 0 matches with 3.6 repeating. 1 matches with 3.5, 3.5. 2 matches with 3. 3 is the error. 4 matches with 5. 5 matches with 4.5. And 6 matches with 4.3 repeating. So again, the horizontal asymptote matches the +4. So 1, 2, 3, 4. Here's my boundary line for the horizontal. The vertical asymptote deals with the bottom of your fraction. But again, that's your error. So that's where x is equal to 3. So vertical at 3, 1, 2, 3. Okay, filling in the domain. So the domain is all numbers except three, because again, domain is your x, range is your y, all numbers except 4. All right, plotting the dots. So 0, almost to 4, so 3.6 repeating. Over 1, up 3.5. Over 2, up 3. Okay, you got this line going like that. Over 4, up 5. Over 5, up 4.5. Up 6, up just a little bit more than 4. Again, you got this line going like that. Not that difficult, ladies and gentlemen. Use your calculator. If you get stuck with the calculator, well, hope you don't get stuck with the calculator. All right, let's move on. Next, given this graph, find the domain, the range, and then figure out what f of 5 is and what f of x equals -2 is. Again, the first thing that I told you to do on these is write down what each dot is, what's the ordered pair. So the ordered pair for this dot is left 2, so -2, -2. This dot is at 0, 0. Third dot is at 2, 0. Fourth dot is at 1, 2, 3, 4, 5, 2. And the last dot is at 6, -2. Write the ordered pairs by each dot. All right, the domain. Again, small or notation first. Make sure the notation's correct. So you're going smallest x value. Well, the smallest x value is -2. To the highest x value, that would be 6. So the domain goes from -2 to 6. Range is your y values. Again, y is in the middle. And you're going smallest to highest or largest. So the smallest x or y value, sorry, the smallest y value is -2. And the largest y value is 2. So it goes from -2 to 2 on the y-axis. Next one. Okay, 5 is on the inside. Remember that represents x. 5's partner, so I look over there. 5's partner is 2. Okay, this one, the -2 is on the outside, so that's representing the y value. And I look over there and I go, oh, there are 2 answers to this one. So -2 matches with the x of -2, and it matches with the 6. So 2 answers to that one. Okay, moving on. Using the graph from the last problem, carefully sketch a separate graph of the information. Okay, so what I'm going to do is I am going to write down, I'm going to make a table of the original ordered pairs. So my x values again are -2, 0, 2, 5, 6. My y values are -2, 0, 0, 2, -2. So based on my original graph, there are my x and y values. Okay, so this means I'm going to add 3 to y. That looks like toy, doesn't it? Let me separate that a little bit further. Add 3 to y. This means, and remember, when it's inside, we want to do the opposite. So that means we're going to subtract 4 from x. When it's on the inside, it's with x. All right, so here we go. So here's my table, here's my x, here's my y. All right, so I'm going to do the y's first. So I'm going to go -2 plus 3 is 1. 0 plus 3 is 3. 0 plus 3 is 3. 2 plus 3 is 5. -2 plus 3 is 1. Now I'm going to do my x values. So I'm going to subtract 4 from each x. So -2 minus 4 is -6. 0 minus 4 is -4. 2 minus 4 is -2. 5 minus 4 is 1. And 6 minus 4 is 2. Let me double check, make sure I got all that right. Looks good. Okay, now we're going to graph it. So left 6, up 1. Left 4, up 3. Left 2, up 3. Whoops, hold on. Made a mistake. Back up. Left 4, up 3. 1, 2, 3, 4. 1, 2, 3. There we go. Left 2, up 3. Right 1, up 5. Right 2, up 1. Connect the dots with the same picture that you have with the lines. Okay, so this one, it translated left 4 units and up 3 units. Left 4, up 3. Okay, new graph. So again, what is the domain? Let me write my ordered pairs in here. So it looks like this dot is at -7, 1. This dot is at -4, 4. This dot is at 0, -2. And this dot is at 5, 0. Okay, the domain, again, smallest to largest for x. The smallest is -7, and the largest is 5. Range, again, smallest to largest for the y value. The smallest y value is -2. The largest y value is 4. Okay, -4, next one. -4 is the x value, and its partner is 4. And this one here, the 1 is on the outside, that's the y value. And its partner is -7. All right. Now we're going to take those and we're going to move it. Okay. So we're going to need to write down the, we're going to need to make a table, but I'm going to do it on the next page. So the original table for the ordered pairs, again, the x values are -7, -4, 0, 5. The y values, 1, 4, -2, 0. Okay, now we're going to change them. So again, this means minus 2 from y. This means add 5 to x. All right, again, I'm going to start with my y values. So 1 minus 2 is negative 1. 4 minus 2 is 2. Negative 2 minus 2 is negative 4. 0 minus 2 is negative 2. Now the x's, I'm going to add 5. Negative 7 plus 5 is 2. Negative 4 plus 5 is 1. 0 plus 5 is 5. 5 plus 5 is 10. Okay, if you think about it, this one's going to move right 5 and down 2 from the original. Okay, here we go. So right 2, down 1. Right 1, down 2. I mean up 2, my mistake. Right 1, up 2. Okay, pause here a second. Let me double check numbers here. Oh, yep. Hold on. Sorry about this, ladies and gentlemen. I'm not going to record this whole thing. So we're going to back up. I made a mistake right here. This is negative 2. My apologies. Negative 2. Negative 7 plus 5 is negative 2. Sorry about that. All right, so here we go. So I knew the graph was messed up before I even got very far on it. So left 2, down 1. Right 1, up 2, right 5, down 4, and right 10, down 2. Okay, that looks better. When I drew that second dot, I knew right away that it wasn't right because the dots were not going in the same order. So sorry about that. I did make a mistake. Negative 2. Negative 7 plus 5 is negative 2. All right. Okay, moving on. All right, follow the path here, ladies and gentlemen. So we've got function g here, function f here. So f of 6. So remember, we go over to f. Here's 6. 6 goes to negative 2. So now we go over here to the g, and we go to the negative 2, and negative 2 matches with 4, so that's our answer. The next one says G5. So we're going to go to G. We're going to go to 5. It matches with 7. Now we're going to go to F7. So we're going to go over here to F7. 7 matches with 1. 1 is our answer. The next one says G5. So again, we're going to go to G. We're going to go to 5. 5 matches with 7. But then it says G again, so we're going to go G again, but we're going to go to the 7. 7 matches with 6. 6 is our answer. Follow the path. Okay, if you need to rewind and watch that again, do it again. All right, next part. We're going to plug the numbers in. So we've got F4, so we're going to start F4 equals negative 3 times 4 plus 2. We're going to get that answer. Negative 3 times 4 plus 2 is negative 10. Now that's going to go into G, because G is on the outside. So G negative 10 is going to equal 2 times negative 10 minus 5. 2 times 10, negative 10 minus 5 is negative 25. And that's our answer. Okay, next one is G. We start with G6. So that would be 2 times 6 minus 5. 2 times 6 minus 5 gives us 7. Now it's function f, so now we have f7, which would be negative 3 times 7 plus 2. Negative 3 times 7 plus 2 gives us negative 19. So our answer is negative 19. Okay, the last one on this page, it has the function f twice, so we're going to go f negative 2. So that would be negative 3 times negative 2 plus 2. And I believe that's going to give us 8. Now we're going to use the function f again. So f of 8 equals negative 3 times 8 plus 2. And that's going to give us negative 22. So our answer is negative 22. All right, the last page. Okay, we need to do a little cumulative review here, little geometry. All right, which congruence theorem justifies why the two triangles are congruent? Okay, remember, these are the ones that are possible. We've got angle, side, angle, 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 side, 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 angle, side, or hypotenuse, leg. All right, so looking at this first one, we notice that there are markings on the triangle. We've got 2 dashes here. We've got a dash here, and we've got a curved line in this angle. The same marks are on the other triangle. Okay, now if my memory serves me, this is a side, this is an angle, this is a side. This is a side, this is an angle, this is a side. So I bet the theorem that justifies that they are congruent is side, angle, side. Okay, the next one, number 20. I'm looking at some markings again, and I see that there's a single marking here. Okay, well, that's a side. No, that's an angle. What am I saying? Okay, that's an angle. So this is an angle. Matches with that angle. Here's 2 curved lines. That's another angle. Okay, well, it's looking like, okay, there's 2 A's in it, so that either gives me this choice or this choice. Okay, well, they share this side. So it must be angle, side, angle. That tells us those 2 triangles are congruent. Okay, the next 2. All right, solve for x. Oh boy, we've been doing this. Take the square root of both sides, so x equals, now don't forget when you do solve an equation like that, you got to put a plus and a minus or a positive and negative in front. 9, so x equals positive or negative 9. Same thing with this one, square root, x equals positive or negative 16. Okay, the next part, write 4 equivalent fractions for the given fraction. All right, well, you have options here. You can either figure out what to divide the top and bottom by or multiply. So I think this first one, I'm seeing 8 and 12. I know I can divide by 2. So 8 divided by 2 is 4, and 12 divided by 2 is 6. That is one possibility. Okay, another possibility, I believe I could divide them by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. Okay, that would be equivalent. Now, dividing is not the only option. I might decide, oh, well, I could multiply these by something. So I'm going to multiply the top and bottom by 2. Again, I'm always using the original. So 8 times 2, that is 16. And 12 times 2 is 24. So that would be equivalent. And I'm thinking, okay, how about just multiplying by 3? Again, there's all kinds of answers here. These are not the only 4 answers. All right, so I'm going to go, okay, 8 times 3, that would be 24, and 12 times 3 would be 36. So there are 4 possible answers to number 23. Now, number 24, 3 over 7, I don't think that can be reduced in any way. I cannot divide by anything, so I'm just going to stick with multiplying. So I'm going to start by multiplying by 2. So I believe that would be 6 over 14. And then I think I'm going to go ahead and multiply by 3. Not going to make this too hard on myself. So 3 times 3 is 9. 3 times 7 is 21. Okay, then I think I'm going to go ahead and multiply by 4. Let's see, 3 times 4 is 12, 7 times 4 is 28. Okay, one more, and I think I'll just go with 5. Okay, 3 times 5 is 15, 7 times 5 is 35. There are equivalent fractions. All right, moving on to number 25. Almost done here, ladies and gentlemen. All right, determine the value of x in the rhombus below. Well, that would be that angle. Now, what we see here, since this is a rhombus, that tells us that this angle and this angle are the same. Okay? If those two angles are the same, that will help us a lot, because what we can do is the following. All right, we know that I can make an equation now. Okay, so I'm going to ignore this this bottom part was useful in helping me figure out that the two angles are equivalent to each other. So I'm going to make an equation. Okay, there are two x's, 2x. So those are the two angles, plus the third angle, 144. Now, if you remember, the angles in a triangle add up to 180. Again, I have two angles that are the same size, so I have two x's, plus the third angle, 144, equals 180 degrees. Now, I'm going to solve this. So I'm going to take away 144 from 180, and so the two angles, between the two angles, there's 36 degrees. Divide by 2, that will give me what one angle is. So that must mean the answer is 18 degrees. So one angle is 18 degrees. All right, and finally, these last two we're going to solve. Okay, well, if you remember, we can, okay, first thing I'm going to do is I'm going to multiply both sides by x, because x is in the denominator. I don't want it there. So what I have is I have 15 equals 5x. Divide by 5. So I find out that x equals 3. Okay, not that difficult. And finally, I'm going to do the same thing here. What I'm going to do is I'm going to multiply both sides by x. So I have 6 equals 12x. Divide by 12. And I get x equals 6 over 12. Okay, that's all nice and dandy, but I should always reduce. And that reduces to a half. There we go. That is what you are expected to know for the last unit of semester 2. Good luck.